Hi, time for another math easy solution. Now we're going to discuss power functions again. We're going to revisit it and we're going to look at some graphing of it. Before, when I did power functions, I went into detail of how to actually calculate it. This time we're going to look at more of the patterns of graphing and whatnot. So let's say if we have a function fx equals x to the power of a. This is basically a power function, and a is equal to a constant. And we'll look at several cases. Well, let's look at case 1. We'll have a is equal to a positive integer. It's positive integer, meaning it will just be, so you go out like 1, 2, 3, 4, etc. So it just positive whole numbers. And then, so if we were to graph, let's say a equals 1, if we were to graph this one, we'll just get, well, it's just going to be a straight line. This is y. That's x. So that's just going to be a equals 1. If a equals 2, this one's going to be a parabola. And then this is x, y. This is just going to be a parabola. And then 0 is the lowest point. And then if you were to go, actually a equals 3, this one is it's similar. Yeah, it's going to be asymmetric here. It's going to go like a parabola there, but then it's going to go downwards there. So this is y, this is x. And then if you were to go a equals 4, now this one is pretty interesting. It's actually similar to the top at a equals 2. So this one's actually looks very identical. It looks similar to that one. And then if we were to go a equals 5, this one will actually look the same as a equals 3, looks like it. This is y, this is x, and this one actually looks like this. So as you can see the pattern. Basically for a equals 1 is going to be a straight line. It's going to be a straight line. For odd, you'll just have it like, it will just look like this. So that's how the graph looks like. And then even. Now for even A's, we'll just have it like parabola. So yeah, you can actually see a pattern, and it'll help you out if you were to graph later on. But now I'll show you some. If you zoom in on what they actually look like, I'll show you what it looks like. And I'll just drag this in here. I'll actually show you the difference between them actually. So if we were to Google search again, we're going to use the calculator. Let's look at the even numbers. Let's go x2, x4, and let's just go x6, I guess. Yeah. So what actually happens here? So they all are like a parabola shape. I'll just zoom in there. Yeah, so they're all like a parabola, but as you can see, this is the x squared. As you can see, like when it's less than 1, if I zoom in, I'll just zoom in a bit more. Oops. Just zoom in horizontally. Yeah, so we'll just zoom in. I'll just show you what it is. Drag it up here. Zoom in just to get to the ones. Okay, so yeah, this is a good graph. So as you can see here, this is this curve here is actually x squared. It's blue. So there's the blue is x squared. As you can see, when it's less than 1 or negative 1. What's in between here, it's actually greater than the x 4, x to the 4, and x to the 6. That's because when you have this is going to be, I'll show you that when it's a fraction there. So this, when it's less than 1 or there, it's larger, but then as you get greater than 1, it becomes, it's not as steep as this one. This one's x6, that one's the steepest. So as you can see, when you go to infinity, actually, when close to infinity, actually, basically goes to close to 1, it goes up. Yeah, so this is how the graphs actually look like. They look similar, except you have this property there. Now if we were to go, graph, let's just get a new tab. We'll go again. We'll graph the cubic ones. Now we'll go, this is x1. Yeah, just go x to the 3, x to the 5, and enter. Yeah, so what you can see here, this one is similar to the other one. I'll just zoom in some more. Zoom in horizontally. Zoom into the one. And then drag it here. Zoom in vertically. Yeah, so as you can see, again, when it's just x to the 1, when it's less than 1 or negative 1 there, when it's in between that, it's actually yeah, it's actually greater than these or more negative here. So as you can see, it's more negative there, but then once it gets greater than 1, the x to the higher power is more steep. So this one is at least steep over here, and then it goes all the way up. So this is an interesting pattern. And as you can see here, this is x to the 5 is x to the 3. So you see this pattern, but then x to the 3 is the lowest here, and it's the lowest there. I'll explain this one here. Yeah, so yeah, basically when you have between, let's say, -1 and 1, what actually happens, when you'll have, let's say, for example, x to the a, but then this is -1, and this is like 0.5, let's say 0.5. So we'll have like 0.5 to the a. So when you have a fraction, if you have, let's say, 0.5 to the 2, this equals to 0.5 times 0.5, and this is actually, yeah, so you could see that half of a half, this one's actually just equal to 0.25. So, but then if you have, yeah, 0.5, or this is the same as 1/2, let's go squared, or cubed, let's go cubed. This one will just be equal to 1/2 times 1/2 times 1/2. This is 1/4. This is 1 times 1. So this one will be 1/8. So this one's actually less than this one. So as you can see, the higher the power, the less the number is. So that's why it was like that. And then when you get greater than 1, you're just going to exponentially get bigger. Okay, now let's look at a different, another. Okay, now we'll look at the case where, let's go a equals 1 over n, where n is a positive integer. So yeah, this one integer, like again, like 1, 2, 3, etc. So if we were to look at, let's say, graph a equals 1/2, so this one would actually just be x to the 1/2, and if you were to graph this one, graph is x, this is y. This one's just going to be like a parabola like that, and it's only defined for here. And that's because if you have, yeah, that's because if you have, let's say, y equals x to the 1/2, if you were just to square both sides, you'll have x squared equals to, yeah, x squared equals x. So basically we're just graphing the positive side of this equation. If this would be, so then if you were to flip this around, so as you see the parabola here, this would be a parabola here. If you were to look at it this way, if you were to graph x and whatnot. And then if you were to graph, let's say, a equals 1/3, this one is actually, this will look like this. X, y, yeah, this one will actually look like this and go down here. And that's because, again, if you look at it this way, if you go y equals to x to 1/3, if you cube both sides, you'll just get y3 equals to x. And then this one is just, now if you think about, if you just like reverse it here, before we had, say before, we had y equals x cubed, and then this one, it looked like this, it looked like this, kind of looked like that, but now it's the same thing here, except we're flipping it over to this side. And then when you have, if you have a equals 1/n, if n is even, it's going to look like this one all the time. It will look like this one. Yeah, if n is even, the pattern's just going to be like this. If n is odd, you're just gonna have the same thing like this one. So that's what you look like. So you basically have graphs like this. It's almost identical to what we did here, except now it's gonna be flipped over to the x side. So all you're doing is it's like flipping it. Alright, so that's this case. Yeah, and then this one's actually just called the let's just call this one. Yeah, this is actually just called the root function. Just write that down. And we'll look at one more case today. Okay, so let's say case 3. This one we'll look at when a is equal to when a goes to -1, and this is just called the reciprocal reciprocal function. Yeah, so if we have a equals -1, we'll just have y equals to x -1, and then this one is just equal to, if you saw my other video on the power rules, we'll just have 1 over x. And then the graph of this one will just be like this. We'll have, and this one's y, this is x. This graph actually just looks like this. When x is 1, you'll have 1 here. 1, 1. Then when x is infinity, it goes to 0, and when x goes to 0, it goes to infinity. So this is this is 0 here. So as x goes to infinity, 1 over x goes to 0, and vice versa. And then if you go to the negative side, it's going to be similar to that, except it's going to be the negative now. It's going to be like this. And this is asymptote there. Yeah, so this one is, again, this one's -1 for 1. It's -1, that's 1. So that's basically how this curve looks like. Well, that's all for today. Hopefully you learned some patterns on graphing, and basically this root function is basically just the opposite of it's just like rotating in 90 degrees of a regular power function. Well, and thanks for tuning in. There's a patterns area. I hope you learned patterns when you graph with different integers on the power function. Well, that's all for today. Hopefully you learned, and stay tuned for another Math Easy solution.